السلام عليكم ورحمة الله تعالى وبركاته. Can you hear me? Okay, let me check. Please confirm, can you hear me? Okay. So, assalamu alaikum wa rahmatullahi wa barakatuh. Thank you all for joining me to this session. My name is Mohamed Berrimi. I am a PhD student at University of Ferhat Abbas. I am the DC lead of my university, GDG Steve co-organizer. You can find me at Mohamed Berrimi on Twitter. So first, I would like to thank all Google MENA team for their effort, for their support. Thanks, Salim, Omran, Sayed. Thank you all for this contribution, for creating this initiative. Together we learn. Okay. So my talk today will be about natural language processing. So this is a field that I have great passion about, that I really love. I'm actually doing my PhD research on natural language understanding and natural language relation. So let's start. This talk will present, first we'll be talking about the textual data, the amount of generated textual data per day, per minute on all the world. Then we'll be talking about some natural language processing application, meaning we're gonna see if NLP is really used to solve real world problems. Then we'll be moving to how can you make your own machine learning model that works on NLP. Then I'll be talking about how did we use NLP on our solution challenge, how it helps us. Then I'll give you some useful resources to start learning your journey. Okay, so some statistics first. Every minute of the day, 156 million of emails and more than 400,000 tweets are being sent. Generally, all this data is text. Okay, on USA only, 26 billion SMS are being sent per day, and basically they are text. There are more than 15 million of Wikipedia pages are actually now, and maybe more at the moment. So as data scientists, as machine learning specialists, we just know that we can't neglect and just ignore this amount of data. We know that if you have enough data, we can do really cool things. So all this data, all this text, we have to explore it and mine it in order to solve real world problems. Another thing, we have a variety of natural languages. We have more than 6,000 languages, natural languages. There's Arabic, Chinese, French, Spanish, etc. And also there is what we call اللغات المشتقة. So for example, in Arabic, we have what you call dialects, درجة. So for example, if I start now talking Algerian dialects, or my friends, Moroccan friends start talking their dialect, maybe only few people we understand them. Okay, so we have two problems here. We have variety of natural languages. We have more than 6,000 languages, and we have a huge amount of generated textual data. So this is a problem where humans actually, it's impossible that he can speak more than 100 languages, that he can translate more than 1,000 languages, or a man to explore or to read all text and mine them in order to make useful things. It's really complicated for humans. So we need an automated tool that understands the variety and the complexity of this unstructured data. So we have a variety of languages, and we have complexity and a huge amount of data. Unstructured data, meaning that when we collect this data, it's almost unstructured. Okay, so this where the word of natural language understanding appears. So natural language understanding, it's about trying to understand how people are communicating with each other. So we need to understand how people are communicating with each other, and how can we get a computer to replicate that behavior so that we can interact with computers in a more natural manner. So a human can communicate with each other. How can we explore this thing and just give computer the ability to do such thing? This definition, according to Google research team. Another definition of NLP, it's natural language processing, is a subfield of machine learning. So now we are studying machine learning application that facilitates human to machine and machine to human communication using and voice, text and voice, because our natural languages are basically text or voice. Okay, this is the tool that we use to communicate with each other. Our task then here is to create machine learning models that enable computers to decode and even mimic the way a human communicates. Okay, so this is our task then. So we need to collect these data and create machine learning models to make useful things and application using this data. Okay, so the question here, is it possible? Is it possible that an AI system or a computer to understand more than 100 languages, or to mine and process all these texts? Is it possible? This is what we are going to explore further on the slides. Okay, so just before we start, there is a question that I really like to ask before starting any presentation. Is it really worth it to learn NLP? Okay, for example, we are computer scientists. We are at least enthusiasts of computer science. So we have a lot of things to learn. There is game development, web development, there is web security, Internet of Things, machine learning, AI. There are a lot of things that you have to learn. And there is only some few time. Okay, why should you pick NLP over those things? Okay, let's show some statistics. There is an application, a website, a Google service that's called Google Trends. Okay, so Google Trends is a service provided by Google that gives you the ability to check and know how much people are looking for that information or for that word. Okay, so for example, we wanted to test machine learning, blockchain, Internet of Things, because they are the most useful, most common things that people are trying to learn these days, or the past 5 years. Okay, we try to compare, and we see, as we can see on these graphs, that machine learning is more widely researched on Google search engine. Okay, so we can now say that, okay, let's pick machine learning. Okay, but as we know, machine learning has many applications. For example, it has image processing, it has natural language processing, it has reinforcement learning, robotics, etc. So we tried to compare these three things. So machine learning have many applications, but we just will try to compare these things. So we have natural language processing, and we have image processing, and we have reinforcement learning. And as you can see, people are searching on Google search engine more NLP more than image processing or reinforcement learning. So it's really worth it to learn NLP, because it's really growing, and the interest of this field is growing year by year, especially on the year of 2017, where the Transformers model appeared. Okay, so the answer out of this question is NLP really worth it to learn? Yes, it's really worth it to learn it. So just follow me. I'll give you some applications, some useful resources to start learning it. Okay, so NLP applications. So this section will give you some real world applications, and we're gonna answer the question: is it widely used? So okay, NLP is good. So now, is it used to solve real world problems or no? Okay, this is what we are going to see, and we're also going to see that you have used all these things, but you just don't know that this is NLP. Okay, so the first example is search engines. Okay, we all use Google search or Bing, etc. So Google search engine is the most powerful search engines ever. So the task here is to receive the user input. Okay, so receiving the user input, query, as we can name it query, and how to decode and understand the meaning of this query. How can we know that what the user is really looking for? Then we start looking back to our big database, because Google has the hugest database ever. So we have done this query, then look back to our database and get back to the user with the most relevant documents. The result can be document, can be text, can be videos, etc. And the query can also be a voice, can be text, can be image, etc. So this is a real tough task. It wouldn't be possible without the use of what we call information retrieval systems. So information retrieval systems is a part of natural language processing. Another example in Google search, the autocomplete. Okay, so the autocomplete is trying to understand or to predict what you are going to type later. Okay, based on what you have typed. So now, as humans, so the next word we are going to say, it depends on what you have said earlier. Okay, so Google here is trying to understand what you have typed and trying to predict what you are going to type later. Okay, this task we call the language modeling. Okay, we are going to see an example of language modeling later. Okay, also in search engines. Okay, this is the most important part, task that I really like on Google search. So now, as computer scientists, we have all this issue of looking to tutorials, how to do this, how to install this, how to configure this, etc. So we really need videos to show us really useful things. And sometimes you look to a video, you start watching that video, but maybe after 3 or 4 minutes, then the mentor tries to explain what's the problem, because he's trying to explain his name, his society, the problem, the configuration, etc. Then maybe after 3 or 4 minutes, then he starts showing us the solution. So Google have tackled this problem and provided a solution. So the solution can be, so understand the user query. Let me do a pointer. Okay, so understand the user query, and based on that, we get back to the user with a video that corresponds to that query, but we have to understand that video and get back to the user with a suggested clip that contains only the solution. Okay, so you can just try to look for it to give more examples. So the key idea is I will give you the part of the video that contains the answer to your question. Okay, moving on. Grammar check. Okay, so this is one of the most important things when we are typing or texting someone, especially when you are emailing an important person. This really embarrassment sometimes, especially if you type from someone from the USA, the UK, and you miss spelling and the punctuation aren't good. So this is really embarrassing. So there is tools, actually. There is not just one tool. So the tool that I really like, it's called Grammarly. Let me show you this link. Okay, be shared on the comments. Okay, it's grammarly.com. You can just go here. So you can just install it and embed it with your Chrome extension as a Chrome extension. So this is so it's basically trying to understand and try to correct your grammar. Okay, so compose bold, clear, mistake free. So mistake free, there is no mistakes, and it is a Grammarly AI powered assistant. So this is AI. Okay, so as we can see here on this email, it tries to correct your words. It gives you later your email or your post looks like. It's embedded on mail, Outlook, blogs. So the grammar is the spelling. It also corrects your spelling, okay, and gives you why you are mistaken. Okay, it corrects also the punctuation. your text will be concise. Okay, this is a really useful tool. I really advise you to use it. It's called Grammarly. Back to our slides. Sorry. Okay. Machine translation. Okay, this is the most important and the real application of natural language processing. It's to try to understand the language and translate it to another language. Okay, this is really tough task. Wouldn't be possible at the 2012, I guess, by Google research team, and especially by Geoffrey Hinton and Yoshua Bengio. Okay, so the task here is to receive a sequence, an input sequence, and output a sequence. So the input sequence and the output sequence have the same meaning, but in different languages. Okay, so you might have, so there is not just Google Translate. There is deepl.com. It's a powerful translation tool, but this is an ongoing research. Okay, what I mean by an ongoing research, so meaning that there are many research labs, teams are to propose the most important, most powerful tool to translate text. Of this research, a system called BERT, bidirectional learning information from transformers. This is the state-of-the-art in machine translation systems and many applications. Okay, so this is a real-world NLP application. Moving on, sentiment analysis. Yes, this is one of my greatest fields of NLP. I'm actually working on project on sentiment analysis and on opinion mining. So the task here is try to read the comment or the post or the message and to predict or guess what's the feeling of this user. So these systems are really useful in e-commerce systems. So for example, if you are selling products, and of course your products, of course your platform will have what we call rating systems. We have reviews, we have comments, etc. So you won't be hiring someone to read all the comments and back to you the like this and like this. This will be a time consuming and an effort consuming and money consuming, etc. So why wouldn't you just deploy an AI model that goes over all these comments, read comment by comment, and try to classify it and get back to you with the feedback and tell you, okay, the hat is good, the t-shirt is bad. So after this analysis, you are going to try to enhance and make your services look better. Okay, this is a real-world problem that was really enabled by natural language processing. I will give you also some real examples on the end of the slides about sentiment analysis. Okay, so chatbots and phone assistants. Okay, so these are real-world NLP, NLU, and natural language generation tasks. I believe that ASC have really about chatbots. I will talk to you today about an example of phone assistant. Okay, so we have Google Assistant, we have Amazon Alexa, and we have iPhone Siri. There is Cortana. There are many. There is also I think it's called there is also a phone assistant on Arabic. Okay, and it's really good. So these are a phone assistants that really helps you. So basically, what they do and inputs. So they receive an input. An input can be text or voice. I hope you are familiar with the phone assistants. Okay, so when it receives the So the process is like this. So it tries to decode the language. Then when it detects the text, it tries to understand the meaning of this query. Okay. After it understands this query, it tries to generate text or voice that corresponds to that question or to that query, and get back to the user. Okay. So we have two tasks here: natural language understanding. So it processes and understands the meaning of the query. Then it generates text or voice to the user. So this great use of NLP. So for example, this is what I am going to explain in a natural manner. Okay, not the answer. So the answer here should be natural. Okay, so the language here should be natural, not robotic. Okay, so for example, if I ask someone, if I ask Google the weather in city next week, so some of you, let's just say, will just sorry. So some of you will say, okay, let's do this algorithm. Okay, the algorithm say the day, it will be the temperature and condition. Okay, let's just try this. Okay, so the user will say, according to his algorithm, the user will say, okay, on Friday, it is 12 degrees and rainy. On Saturday, it is 14 degrees and cloudy. On Sunday, it is 18 degrees and cloudy. Oh, this is sound more robotic and not natural at all. Okay, that feeling, well, okay, this is a meme. Okay, so this is not natural. We don't need a system or an assistant that looks robotic. We want an assistant that looks more human. Okay, so according to Google Siri, Google Assistant, sorry, the answer of Google Assistant will be, it will be cloudy until Monday and rainy the rest of the week. Temperature range between 14 and 18 degrees. This sounds more natural. Okay, this is what we want. The natural language understanding and the natural language generation would be look like. It would be look like more natural to human communication. Okay, moving on. Event extraction. This is a really good field. So this is what we call a naming entity recognition. So I'm gonna show you some example. Okay, where is Alan? So you just can go to Alan NLP. Okay, so Alan NLP is a platform where they deployed most of the language models, and we'll give you a demo. Okay, so name entity recognition. Name entity recognition is a model that identifies name entities. What we mean by name entities: people, location, organization, etc. So I will give you an example. So let's say Aya or Mohamed is Apple fan because he loves MacBook. Okay, just an example. Okay, and let's run it. Okay, so it's automatically detected that Mohamed is a person, Apple is an organization, and MacBook is a product. Okay, so it tries to read the text, read the input text, and detect what are the entities that I can detect here. So using these name entity recognition systems, you can create great cool application. So for example, food hazard event extraction. So it's a project of friends of mine. So it's really crawls the Facebook posts or Twitter posts and tries to detect if there are events that's correlated or related to food hazard. Okay, this is an event. So it will detect the events, the amount of food facet, and the place, etc. So this is a really good example of name entity recognition systems. Okay, another example is called video and image captioning. Okay, now you are as you are watching on YouTube, and we always watch YouTube videos, and we see what we call the captions. Okay, so the captions is trying to look back to the user and tries to understand what the user is really trying to say. Okay, so this is a computer vision task and an NLP task. So they are مجموعين مع بعض to provide these systems. So video and image captioning. This is a real great field of NLP, and this is an ongoing challenge to try to predict what the image contains, what the user is trying to say. So as you can see, that YouTube gives captions, but sometimes it fails. But they are trying to give more and more robust models. So this is an ongoing research, and I really like these examples. So many more. We have many more applications. For example, I will show you this example. Okay, on forms, Google Forms. I hope you all use Google Forms. So this is the testing form. Okay, so here, for example, here you have an input. Okay, so for example, you are trying to say this should be a name input. Okay, it automatically converted to a short answer. Okay, let's just try description. As you know, description should be a paragraph or a long. It automatically converts to paragraph or. So for example, if we say that this is an option field, okay, if we write here that this is an option, it automatically converts to multiple choice. Okay, this is, so it's right to understand what the user is typing here and convert these options. Okay, so for example, the age is a number, so we expect it to be a number here. Okay, age. Okay, so short answer and a number is a number. Okay, we have to. So this is a good application. I don't know if I have other examples. No. Okay, so there are many other applications. Okay, so now after we have seen the applications, so can we develop such systems or not? Okay, so this is what we call NLP pipeline towards building your model. So from data to machine learning model. Okay, but first, in all machine learning projects and all data science projects, we need what we call data. So data really matter. So since this is text or voice, we can collect it from blogs, websites, social media, such as Twitter or Facebook, online books, etc. So you have to crawl or what we call scrape all these data manually, or there are some tools that you can use. So this takes a lot of effort, actually. So sometimes, why don't we just pick data? Okay, so you want data. Here's your data. I will show you a website that contains more than 200 data sets. Where is it? So this website called the Big Bad NLP database. Okay, so QuantumStat, dataset.quantumstat.com. It will be shared with you on the comments. Okay, so this website trying to collect all the data available. So there's an Arabic, there's English, multilingual, there's Chinese, there's French, Spanish, all the languages that you need to collect. Okay, there is also data that contains more than 1 million text, 20,000 text, etc. So this is a real good direction to start collecting your data and picking up your data. Then you go to create your application or you do your research, etc. So I really advise you to start here. And also it gives you the data set, the language and the description, and also the paper related to this data. Because usually all the data published, it remains to it's related to a paper. Okay, so back to our slides. So after collecting and picking up your data, this is what you are going to do. Okay, so first you are going to tokenize all your data. Meaning by tokenize is breaking down a stream of text up into words or phrases or symbols or other meaningful elements called tokens. Okay, for example, if this is our input, this is our input sequence, our sentence, so we have to tokenize it to words, okay? Because later on, we are going to construct what we call the index, okay? After this, we are going to clean in your data. So this looks like the pre-processing phase of machine learning models. So you have to remove links, remove punctuations, stop word removal. So you are going to remove what we call bruit en français. I think you have understood me. So you have to remove all the data that will affect your model negatively. Okay, so what we mean by stop word removal, so meaning that this all the data, all the words that don't actually add a value to your model, but they are repeated a lot. For example, the word the, for example here, in or is or that. So these words usually are repeated a lot in a sequence. For example, a, okay, up, off. So they are repeated a lot in a sequence, but they don't add much. They don't add much value or meaning, much value of the meaning to the sentence. Okay, word normalization. This is an optional step. You can skip it. So the goal here is trying to reduce the morphological variation. So this is an example of it. So plays are playing and played. They will all be converted to one single word called play. Okay, so this is the root of this word. So جذر والجذع, okay, of the word. Okay, so are, is will be converted to the verb be. Cars, car, etc. will be converted to car. Okay, so now we are trying to reduce the morphological and convert it to the root of the words. So, and finally, we have to, so as we know that machine understands only numbers, okay? Understand only numbers or vectors, okay? So we need to transform our text into something that machine can manage. So we know that machine can't just manage word or an image. So we have to decode it to vectors or to images or to numbers, etc. So, the first application, the first tool is called bag of words. Okay, so bag of words is tries to construct the index. Okay, we have to collect our index, word index. So this is good, bad, awesome, according to our corpus. Okay, then per each okay, sorry, per each corpus, we try to put the count of that word, how many times it occurs on that corpus. Okay, so this is called count vectorization or bag of words. Okay, so the problem with this method is that it doesn't capture the meaning of the text. So the context in which word appear, even when using n-grams. N-grams is another field of vectorizing and normalizing your input sequence. Okay, so this is not robust, and it doesn't add meaning to the text. Okay, so we need another thing. This is what we call a TF-IDF vectorizer. So TF-IDF stands for term frequency inverse document frequency. So it's a weight that is a statistical measure used to evaluate how important a word is to a document in a collection or a corpus. Okay, so we need to weight all the words according to their importance. How do we collect this weight? So the importance increase roughly to the number of times a word appears in the document, but is offset by the frequency of the model of the word in the corpus. So we have TF, it's called time frequency, It's the number of occurrences of that word in the corpus. And there is IDF, determines the weight of rare word across all documents, especially meaning that there are some rare words, but they add the much value. Okay, this means how common or rare a word is in the entire document set. The closer it is to 0, the more common a word is. Okay, this is the type of idea. So until now, we are not really looking for the meaning. So we need a form of representation so that similar words are close to each other. Okay, so we need a form to understand a word. So we need a form to understand all the words, and the words that have same meanings should be close to each other. Okay, when we encode them to numbers. Okay, so this is what we call word embeddings. So it is the dominant approach to represent words to be more semantically meaningful. Word embeddings are in fact techniques where words are represented are real valued vectors. So we are transforming our words to vectors. Okay, and in a predefined vector space, each word is mapped to one vector, as I have said, and learned. So it is learned like the neural networks. Okay, like the propagation algorithms learn to weights on images, etc. So the weights here are actually learned. This is a good blog on towards data science called Introduction to Word Embeddings and Word2Vec. So Word2Vec is basically the algorithm or the technique that was proposed by Google that is destined to calculate the word embeddings. So this is a good blog that I really advise you to read. Okay, on how to calculate the word embeddings. Okay, moving on. Okay. Just one example, another example. There is a fast AI example. Okay, this word embeddings. So, for example, sorry. Okay, so here they have read all their data. Okay, this data set that contains words collected from Wikipedia. Okay, so for example, if we try to print the embedded vector of each word. So this is a word. Okay, this is an ID of a word. Okay, so this is how the word is really represented. Okay, it is represented by a vector, and the length of this vector is determined at the beginning when you are going to encode. Okay, so for example, if you are trying to calculate the distance between the word puppy and dog. Okay, this is the distance. Okay, cosine similarity, a cosine distance. Okay, we see that it's 0.27. Okay, this is a really small value. And for example, if we are trying to compare kitten with an airplane, they are not similar. So they are a far distance. Okay, so avalanche and antic, they are much distanced. So puppy and dog, they are very close. Queen and princess, they are really close, etc. So this is a course by Fast AI. Okay, I will talk about Fast AI later. So Glove is also like a Word2Vec proposed by Stanford University. So just go to Word Embeddings workshop of Fast AI. The link will be shared with you on the comments. Okay. Moving on. Okay, this is Word Embeddings. Now, after you collect your, after you calculate your TF-IDF weights, or you create your embedding layer, you are going to feed it to your machine learning model or your recurrent neural network architecture or your deep learning model. Okay, so now from on, so we have collected the data, we have processed it, we have weighted all the words, And now we are going to feed these weights to our machine learning model or to our deep learning model. Okay, so recurrent neural nets are the distant areas of artificial neural nets. I will talk about them briefly. So one-to-many, for example, if you are going to classify text, so if you are going to do an image captioning, so the input is an image and captions is a text. Okay, for example, here is trying to do a sentiment analysis. So the input sequence is a text. Okay, so there's an input text, and try to predict the class. So here, this is a sequence to sequence a translation. This is translation systems, as we have seen on the Google Translate. This is how they work. So we receive an input sequence, we try to decode them and understand what they are meaning, and then output sequence that matches to that input sequence, but in a different language. So this is video captioning, for example. So we receive each frame of the video, we try to understand it and try to predict which the text that contains that is contained on each frame of the video, etc. So recurrent neural net is the real architecture that really solves all NLP problems. Okay. So now, as you have maybe noticed, I've been talking about natural language understanding and generating. So understanding, it's the step when you are going to try to understand your input sequence after you have processed it. And energy, it takes the data from search results and turns it into understandable language and output it. Okay, so it understands how you are saying things, how you are typing things, and it tries to type things. Okay, this is similar to generative adversarial networks. It tries to understand how the text is combined and tries to output it. Okay, so now we have seen the pipeline, the steps towards building, and we have seen the application. We have seen that this is a great field and interesting field. So what starts? Okay, how do I start learning this? Okay, so useful links. There is the big bad NLP data set. I believe you have already showed you. So this is the big NLP data set. So you won't be collecting the data, etc. So we'll just pick up a data, okay, and start using it. Okay, there is Fast AI course. So if you are familiar with Fast AI, okay, so Fast AI is a deep learning framework developed on the top of PyTorch, okay, and proposed by Jeremy Howard and Thomas Rachel. These are a married couple. Okay, this one have a PhD in maths and he has PhD in ethics. So this is a Fast AI course to introduction to natural language processing. This is one of the best ever natural language processing course. It has understanding RNNs, sequence-to-sequence translation, word embeddings, text generation, LSTM, GRU, etc. This is a real detailed course, and this course is studied at the University of San Francisco. So these are recorded videos from San Francisco University. Okay, and Rachel Thomas is the one who created this framework with her husband Jeremy Howard. Okay, I will show you why you should learn Fast AI. Okay, just an example. Okay, for example, in deep learning, in image classification, for example, if we are trying to classify a MNIST dataset, okay, so we import our dataset like this, just 2 lines of codes, and then we define the CNN learner. This is a predefined method on Fast AI. So CNN learner, we parse it, the data, and the model. This is what we call transfer learning, and the accuracy and fight cycle. Okay, you have build your deep learning model only on 4 lines of code. This is really exciting and fast and easy to learn. Okay, only on 4 lines of code you have developed, and the accuracy is up to 97%, this is real cool application of fast AI. You should really learn fast AI. So you go to fastai.com. Okay, back Stanford NLP course. As I said, NLP Stanford University is on top of research teams that are behind NLP research. So they have their courses are published on the internet. So you go to natural language processing with deep learning. So this is a course developed on, and you can find also this course on. Okay, and you have you will find all these videos on YouTube. Okay, just okay. Sorry. So the Hugging Face library. This is also a library or framework, maybe. Framework developed on the top of PyTorch. It's really used and easy to use. Also, Kaggle kernels. This is useful things to learn NLP. So you go to the competitions that are related to NLP and see how people are really coding this. Okay, and also good things. Okay, so as we have seen, that NLP is a great field of research. So we wanted on our DSC club to deploy some NLP models. Okay, so how did NLP help us on the solution challenge? Okay, so we are working on a project that's called Safe Social Media. Okay, Safe SM. So it is basically a of social media application and mobile application. So we have seen, so the motivation of this work is we see on social media that there is a huge amount of bullying, especially on comments. Okay, there is bullying, there is hate speech everywhere on social media, there is a lot of negativity. Okay, there is political speech, fake news, etc. So we are trying to create deep learning models or machine learning models that understand the comments and the text and try to remove or block these comments. Okay, so we are using TensorFlow, and all our models are trained on Google Colab and Google Cloud Platform. Okay, so this is a great field. It's like sentiment analysis. It's like text classification. It tries to understand the comments, the posts, etc., and try to filter them out. Okay. If you have questions, please type them. I will go and read all your questions. Okay, amazing. Noise. Okay, very thanks. Thank you, Leila. Thank you, Ramzi. Okay, what are specialization? Okay, specialized machine learning in machine learning, and these are in applying learning natural language, understanding natural language, and also generated generation of natural languages. Okay, so my field is trying to understand the variety of languages. Thank you, Sarah. And okay, after you feedback. Okay, there is also you can get a certificate after you feel feedback. I think these are the questions. If you have questions, please type them here. I'll be glad to help you. Okay. Yes. Hello. Can we share this link on our social media? Yes, Ahlam. Yes, go ahead. You can share them. Also, I will be giving you the slides. Okay. Okay. Is there an embedding, a word embedding for Arabic? This is an ongoing research, actually, Khalid. Okay, this is an ongoing research. So you have to collect much data and you have to train like or trying to do like they have done with Word2Vec. So you just have to explore and copy the architecture of Word2Vec or the globe and try to apply it to Arabic. Okay. Thanks for your session. Thank you, Aya. Is there word embedding for Arabic? Yes, I believe that it exists, but it's not efficient as in English. Okay. Embedding is تضمين الكلمات. Try to give meaning, represent a word in a meaningful thing. So there is a next session with my friend. I think. Okay. Elias Bentashafin. If you have questions, please type them here. Okay, thank you, Ilham. Please wash hands and stay home. Please stay safe. Please don't go out. There is any questions, please type. Okay, back to the slides. So the slides will be on bit.ly NLP Mohamed. You can access these slides. Okay, bit.ly/NLP -Mohamed. Okay, NLP. Okay, I'll show you a demo about sentiment analysis. I will say that the event of NLP was really good. Okay, so I'm inputting an input sequence that contains a sentence. Okay, I will run it. Okay, and the answer is positive. Okay, it has classified it as it's a positive answer. So the model here, as we know that this is an ongoing research, there are a lot of research. So this is Glove LSTM or Word2Vector LSTM layers, and this is Roberta. Okay, so this is standard Roberta large. Okay, you can find here the links to the model. Okay? You can pick and choose your model. Okay, name entity recognition. I will show you the language modeling. Okay, these are the language modeling. So, okay, for example, so it tries to understand what I have typed and predicts what I'm going to say. So I miss, it predicts that I'm going to type view. Okay, the food was really okay. Okay, it's predicts I'm going to type. So this is a GPT-2 OpenAI model. The food was really good, delicious, great, nice, tasty, etc. Okay, I believe it will be tasty. Okay, so I have left only 4 to 5 minutes. Okay, I have 2 minutes to finish. Thank you all again. If you have any questions, this is my Twitter account. You can reach me out at any time at Mohamed Berrimi. I hope you all stay safe. Is there a way to find similarity of word alphabetically like home, find type errors? Yes. Okay, these are the slides. Okay, a way to find similarity of words alphabetically. So yes, you can find similarity of words and also similarity of sentences. Okay, there is a challenge called Quora similarities. Okay, it tries to define if question is repeated or not. Okay. Is there so I will back to you, Khalid. Okay, so without so each there is a data set finding similar Quora questions with back of Word, TF-IDF, etc. So we can go here. So this tries to understand if this question is repeated or not. Also, it can be reused to do word similarities. Is there any good resource for NLP and Android apps? What do you mean, Rahaf? And Android apps. You want to deploy your NLP model to your Android or what? I'm not sure that I understand, Raf. Is there any questions that I didn't catch? Okay. So if you are going to deploy your model on a web application or on Android, there is a TensorFlow Lite. You can just, after training your model, okay, I will show you an example, a quick example. Okay, that is, I'm not sure where is it. So the key idea is, after you train your model, you have to save it and use TensorFlow Lite. You can use Flash. You can use a lot of examples to deploy your NLP to Android apps. It's really used, especially with TensorFlow Lite and Flutter. Okay, so TensorFlow Lite. Okay. Okay, I think I have answered your questions. Please stay safe. I hope you liked your this presentation. Please fill up this feedback, and if you want to give me a feedback, you can reach me out. Okay. Okay. Thanks a lot. سبحانك اللهم بحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. السلام عليكم.